You have probably done it. You asked an AI a question, got a confident, well-written answer, and then found out it was completely wrong. Maybe it cited a study that does not exist. Maybe it quoted someone who never said that. Maybe it gave you a statistic that was just made up. And the worst part? It did not hesitate. It did not say maybe. It told you with total certainty. This is not a rare edge case. In April 2026, a major law firm had to submit a formal apology to a federal bankruptcy court after the opposing team discovered their filings contained hallucinated legal citations that did not exist. Deloitte submitted a report to the Australian government containing non-existent academic sources and a fake quote from a federal court judgment. A report they were paid nearly $500,000 to produce. This is called hallucination, and in this video, we are going to explain exactly why it happens, why it is not going away anytime soon, and what you can actually do about it.
First, let's clear something up. When an AI hallucinates, it is not lying. Lying requires intent. The model has no idea it is wrong. Remember from our last video, a large language model does one thing. It predicts the next token based on patterns in its training data. It is not retrieving facts from a database. It is not checking sources. It is not cross-referencing what it says against some internal list of verified truths. It is generating text that looks like the right answer. Usually it is. Sometimes it is not. And critically, the model cannot tell the difference between those two situations. It has no internal alarm that fires when it crosses from accurate territory into made-up territory. It just keeps predicting the next token, confidently, all the way through. So, why does this happen at a structural level? Here is the best analogy. Imagine a student taking a multiple-choice exam with a very specific grading rule. 1 point for a correct answer, 0 points for a wrong answer, and 0 points for leaving it blank. What is the rational strategy? Guess on everything. Never leave a question blank. Even if you have no idea, a random guess gives you a chance of scoring. Saying, "I do not know," guarantees you get nothing. This is almost exactly how AI models are trained and evaluated. The vast majority of benchmarks used to measure AI performance use binary scoring, right or wrong, with no credit given for expressing uncertainty. So the training process inadvertently teaches models to confabulate rather than abstain. The model was never rewarded for saying, "I do not know," so it does not, it guesses. And it guesses fluently, grammatically, convincingly, every single time. There is a deeper layer to this called the singleton rate. Not every fact appears the same number of times in training data. Einstein's birthday shows up thousands of times across books, websites, encyclopedias, and articles. A local politician's voting record on a specific bill might appear once, buried in a regional newspaper archive. The model has strong signal for the first kind of fact, and almost no signal for the second. But it does not treat these differently. When you ask about Einstein's birthday, it draws on thousands of consistent data points. When you ask about that obscure voting record, it has almost nothing to work with, so it generates something plausible. Something that fits the pattern of what that kind of answer usually looks like. It does not flag this distinction. It does not say, "I am less sure about this one." It answers both questions with exactly the same confidence. Now here is the part that should genuinely unsettle you. You might assume that when an AI is wrong, it at least sounds a little less sure of itself, maybe a bit more hedged, maybe a little uncertain. The opposite is true. MIT research found that AI models are significantly more likely to use confident language, words like definitely, certainly, and without doubt, when generating incorrect information than when generating correct information. The more wrong the AI is, the more certain it sounds. One researcher ran a simple experiment. They wrote a completely made-up story about Steve Jobs involving a fictional craftsman, a fabricated quote, and a visit that never happened. Then they asked 5 of the most popular AI models whether the story was true. Every single one said yes. All 5.
confidently, without hesitation. That is not a quirk. That is a consistent pattern baked into how these systems generate text. Fluent, confident prose is what gets rewarded during training, so that is what the model produces, even when it is making things up. And some domains are dramatically more dangerous than others. On well-known topics with abundant training data, the best models today are remarkably accurate. But the moment you move into specialized territory, the picture changes fast. Research on legal queries found that LLMs hallucinate on specific legal questions between 69 and 88% of the time. On medical questions without specific mitigation strategies, hallucination rates on complex clinical cases exceeded 64% in one study. Nearly two-thirds of responses containing fabricated information. These are not edge cases or stress tests. This is what happens when you take a prediction engine trained on general internet text and ask it to perform like a domain expert. The model sounds like a domain expert. It does not know what a domain expert knows. You might be wondering, is this getting better? The honest answer is yes and no. The best models today have dramatically lower hallucination rates than models from 2 years ago on many tasks. Some leading models now show hallucination rates below 1% on straightforward summarization and factual consistency tasks. That is real and meaningful progress. But here's the uncomfortable part. A 2025 mathematical proof confirmed that hallucinations cannot be fully eliminated under current LLM architectures. They are not a bug that gets patched in the next update. They are a fundamental characteristic of how these systems generate language. And in a genuinely strange twist, some of the newer reasoning models that score better on complex thinking tasks actually hallucinate more on specific factual questions than their predecessors. OpenAI's O3 hallucinated on 33% of person-specific questions in one benchmark, double the rate of the model it replaced. Getting smarter in one dimension does not automatically mean getting more accurate in another. The relationship between capability and reliability in these systems is not what most people assume. So what do you actually do with this information? A few things that genuinely help. First, use AI for drafts, not facts. It is extraordinarily good at structure, tone, ideation, summarizing things you already understand, and generating first versions of things you will then edit. It is a poor primary source for specific facts, citations, statistics, or claims that will be relied upon by someone else. Second, the more specific and niche your question, the more skeptical you should be. General questions about well-known topics carry much lower hallucination risk than specific questions about obscure ones. Asking what the French Revolution was about is very different from asking for the specific voting record of a minor historical figure. Third, AI tools that connect to real-time web search reduce hallucinations significantly on factual queries because the model is retrieving information rather than generating it from memory. That does not eliminate the problem, but it changes the risk profile meaningfully. Fourth, if something in AI tells you actually matters, verify it independently. Treat every AI output the way you would treat something a smart friend told you at a party. Interesting, worth following up on, not a primary source. The people who get into trouble with AI are almost always the ones who skipped this step. The framing that matters most is this. Hallucination is not evidence that AI is broken or useless. It is evidence that you need to understand what kind of tool you are actually working with. A hammer is not broken because it cannot drive screws. An LLM is not broken because it cannot reliably recall rare facts with perfect accuracy. It is a prediction engine, an extraordinarily powerful one that has already changed how millions of people work, write, and think. And like any powerful tool, the people who use it well are the ones who understand its actual capabilities and its actual limits. The goal is not to trust AI blindly or to dismiss it entirely. The goal is to know exactly when to lean on it and when to verify what it tells you. If this video gave you a clearer picture of why AI makes stuff up, hit subscribe. Every week, we break down something in AI that matters and explain it clearly. Next up, what is a neural network? It is the architecture underneath everything we have talked about in this series, and it is one of the most fascinating ideas in all of computer science. See you then!